Great, thanks everybody, and thank you all for joining us here today for this webinar. Again, the name of today's webinar is Building API-Driven Microservices with Amazon API Gateway, and my name is Chris Munns. I'm currently a Senior Developer Advocate for Serverless here at AWS, technically part of the Lambda and API Gateway product teams. I've been here at AWS for just about 6 years now or so, and have previously focused on some of our other services in our development and management tool space, as well as being a solutions architect here. But previously came from more of what I consider to be an operations or systems administration background. So why are we here today? This topic of APIs and microservices is an incredibly popular hot topic inside of the industry. We'll go through some talking points here today, just talking about how that is growing, how that is scaling, and then talk a little bit about some of the technology decisions that you have to make when it comes to thinking about microservices, particularly in terms of being able to power and manage APIs. I like to start with definitions sometimes, and I find that this definition on microservices from Wikipedia is actually maybe one of the best ones that I've seen. So microservices, again, as defined by this Wikipedia post, is a software architectural style in which applications are composed of small, independent processes that communicate over language-agnostic APIs. Typically, these services are very small, very decoupled, performing just a small little action or task, as it were, with the idea being that you combine these together such that you have a greater whole at the end of the day. And so, again, this term here is incredibly popular, but when we think about APIs, there's a saying by Marc Andreessen, very well-known venture capitalist, that software is eating the world. Essentially, the idea that, whether we talk about almost any industry, any vertical, any segment that exists out in business today, that more and more companies are needing to have specialized software for interfacing with their customers, for interfacing internally, and typically many of their products might be driven, or the creation of those products driven by software. Kind of as a reply to that, Dr. Steve Willmott from Red Hat said, and APIs are then eating software design. And so we see APIs being something that our customers here at AWS are spending lots of time thinking about, asking us lots of questions, and so we're kind of talking about this topic day in and day out. So quick little biology lesson here. I don't know if anyone else on this webinar knows what honeybees have to do with building microservices, and more importantly, the Building Microservices book by Sam Newman. But if you happen to go into your favorite search engine and type in APIs, you might think that you're looking at something about software development, but what you might actually get back is the fact that Apis is the genus for honeybees. So, little side lesson here today for everybody on if you end up doing research on this topic, you might get back information about honeybees. This is the reason why. But in a more serious light here, talking about this topic, if we went to Amazon.com and we searched for books on APIs, you'll find that there's over 1,000 books on this topic today. Lots of books, lots of learnings, lots of things that you can do, both from a research perspective as well as kind of understanding best practices and what's going on out there. We could have an entire webinar, maybe several webinars on structuring APIs. That's a bit more than we could go into really good depth on today, and there are lots of nuances to that. But I would definitely encourage you to pick up a book on this, take classes on it, read things about API design. Again, not a topic we're going to go too in depth on today. We go and look for microservices-based books, again, a term that's a bit newer in the industry. We still find that at this point today, there's approximately 164 books just on this topic. So this is another topic, again, which is, at this point, I think in the industry, well trotted, well exampled, and there's lots of good material for you to be able to read up on microservices. So, feel free to, again, pick up a book, download an ebook, whatever it is that you might need to do. Lastly, in terms of growth and popularity, we here at AWS have a yearly user conference called reInvent. It's typically around the November-December timeframe every year. And we've seen over the last couple of years here APIs and microservices as growing and trending topics at the conference. So for example, here we can see that in 2012 and then in 2013, there weren't any breakout sessions about APIs and microservices. In this case, this is using a tool that provides basically text search for the titles and abstracts of talks at reInvent. However, we see in 2014 that we then had 2 talks on each of these 2 topics. And this expanded in 2015, 2016, and then more recently here in 2017, where there were 8 talks on APIs and 10 talks on microservices. So again, the growth and popularity of these topics is pretty evident. It's hard to go to a technology conference these days and not see a couple different sessions of people talking about their experiences in building both APIs and microservices. So what is it that makes a microservice micro? This is another area where there are a lot of opinions, a lot of sometimes contrasting opinions, I would say, about this. And realistically, this is another thing that we could spend an entire webinar talking about, how you think about slicing and dicing a service, or potentially even building a new service from the ground up to follow certain best practices. The reality of it is that for most of the customers that I've worked with here at AWS, when it comes to working or thinking about building microservices, it can vary very much depending on your use case, depending on your technology, depending on the overall problem that you're trying to solve in regards to your business use case. And so, what I would encourage you to do again here, this is a great place for doing research and reading further about how others have done this. There's a really great book, which is considered kind of one of the leading sources about understanding the space in depth, which is the Building Microservices book from Sam Newman. Would definitely encourage you to take a look at it. I think basically in this book, Sam boils down a lot of concepts around building and software development lifecycle and thinking about managing and monitoring services in a microservices pattern. So again, we're not going to talk too much here in today's talk about things like domain-driven design or bounded contexts or CQRS or stuff like that, as it can be itself a very, very deep topic to talk about. So let's actually talk about the building, supporting, and managing of an API, what it is that you need to think about if you're going to do that. And when we talk to customers about building APIs and API technology stacks, we typically have a couple of common areas that we have to think about. We have to think about what I consider to be kind of the presentation layer of an API. So what does it mean to serve an API out to my customers? Again, whether that customer be internal or external. There's my API backend. So what is the actual technology that's going to ideally represent my business application, my code that I'm going to write, where should that live? And then there's databases and data stores. And I would say typically the most common microservices pattern that we encourage and that we see is you've pretty much got one of each of these. So you consider it kind of a new world 3-tier stack, if you will, of some sort of API server, some sort of API backend, and then some sort of database or data stores. Now, the database and data stores part of this is also maybe a topic a little too big for today, and we definitely have webinars and all sorts of material on understanding what database you should pick for what purposes here at AWS. And so I will leave some of those talking points towards looking at some of those topics yourself. So again, we're primarily going to focus on the API server and the API backend. Now, when it comes to thinking about the API server aspect itself, there's a number of challenges that come with managing APIs. When you think of APIs, it's a little different than thinking about just a traditional web service, which maybe is accessed over a web browser. Typically when we're building APIs, it is for consumption by some sort of client that is purposely built, whether it be, say, a mobile application, a device-based application like an IoT device, or even internal services that might be speaking over APIs. And so the way that we have to think about how a client or the clients that we have might interface with it is very different than the human model of a human, say, clicking around a web page and going from page to page. So, some of the common challenges that we work with customers on is, managing multiple versions and stages or environments of an API, thinking about if you do have to expose your API out to third parties, what's involved in managing and working with that. Access and authorization could be a challenge. So how do you secure your API really well? Thinking about traffic spikes. So, many of you are building applications that are going to see ebbs and flows in traffic. You could have very bursty workloads. What can be done to deal with that? And then lastly, we're talking about a technology that would typically require some sort of management overhead. And so how do you think about finding a tool or tools that will help you reduce the amount of management overhead that you have? And I would say here at AWS, this is something that we spend a lot of time thinking about, how we can help reduce the undifferentiated heavy lifting from our customers. And so here at AWS, we have an API Gateway product called Amazon API Gateway. API Gateway as a product space is not something that we invented ourselves. There are other products that exist out there in the industry. That said, I'm obviously a bit biased here, but Amazon API Gateway is a pretty awesome product. It's a fully managed service that basically allows you to represent an API out to the consumers that you might have of that API-based service. And it's going to take care of all of the kind of goodies that you would expect something like a managed API Gateway service to take care of for you. So, managing different versions and environments, potentially distributing API keys to external developers, throttling, monitoring, DDoS protection, the ability to do things like cache queries and API responses both at the edge and at the API Gateway itself, SDK generation, a number of goodies and things that will help you not have to spend time doing management yourself. Again, API Gateway being what we consider to be a serverless service here checks off a number of boxes. So there is no need for you to manage an operating system or any software or any, say, compute or virtualized instances anywhere. No need to manage containers or anything like that. You can basically put an API Gateway in front of your backend, which we'll talk about backend technologies here in a moment, and away you go. Again, ideally without you having to spend much time doing much, if any, administration of the service itself. Now, API Gateway is a pretty flexible product. It's got a number of different integration points in and out of it. When we first launched API Gateway, we launched it with something that we now call edge endpoints. These are endpoints that are represented by an Amazon CloudFront distribution. So Amazon CloudFront is our CDN service here, content delivery network. There's a little over 100 points of presence globally today, and basically what would happen is your API would be exposed out via DNS representation of these points of presence, such that if you have clients, anywhere in the world, their request to your API would go through CloudFront and then to the API Gateway and then to your backend. A couple of years later, actually back in 2017, we announced something called regional endpoints. This gives you API Gateway without a configured CDN distribution in front of it, such that if you have service requests that exist only inside of a region, you don't have to bother going through a CloudFront POP to serve those requests, as well as allowing you to bring your own CDN configuration. So you could bring another CDN service, you could bring CloudFront with your own configuration in front of it, but this gives you that flexibility. We then also support caching an API Gateway at the API Gateway level. So this is a memory-based cache that you can configure the size of the cache. And so this can be useful for storing API responses before going out to your clients or out to an edge. API Gateway integrates very closely with Amazon CloudWatch, which we'll talk a little bit more about here later. And then on the back end, we've actually got a number of different technologies that we support. And we're going to go a little deeper into these. So assuming that we're looking for a way to serve up our APIs, we're looking for benefits such as managed authentication, authorization, the ability to serve up these API requests in a secure manner with things like SSL, and again, the authorization, authentication mechanisms there, not having to have management overhead, not have to think about scaling overhead, paying only for what you use. API Gateway is a really fantastic solution to get you there. So we're going to assume today in our topology that we're going to use API Gateway. And again, API Gateway is kind of one of the core products in our serverless stack today. Let's talk a little bit about backend options that you have for an API. So API Gateway supports a number of different backend types, which some of these we'll go into more depth in than others. We can back API Gateway with AWS Lambda, which we'll talk about here a little bit more. You can back it also with basically any sort of endpoint that lives on EC2, whether this be actual EC2 instances, whether it be container-based applications, as well as putting it basically in front of any HTTP or HTTPS endpoint that you want to. You can also put API Gateway in front of other AWS services. I'll talk a little bit more about this here in a moment. And then lastly, you can actually put API Gateway in front of any public HTTPS endpoint that you have. So if you're running an endpoint, say, on premises, and you want to put an API Gateway in front of it, you can. You can also put it in front of, say, infrastructure running on Heroku, infrastructure running on, say, other cloud providers, infrastructure. This is something that API Gateway supports, and you still get the same features and capabilities of API Gateway. You can also, as of the most recent reInvent, put API Gateway in front of private resources inside of a VPC. In this case, private EC2-based resources. We've supported Lambda inside of a VPC for quite some time now. So, ability for you to put API Gateway in front of all sorts of different backends. It is not limited to, say just Lambda or just EC2-based things, as well as it can, also support things like on-premises endpoints. From an AWS perspective, we have essentially 3 core compute products at AWS today. We have EC2, or Amazon Elastic Compute Cloud. We have Amazon Elastic Container Service, or ECS, and we have AWS Lambda. When we're thinking about how you want to, potentially back your API, there's a number of different options that you have here. So if we were to think about EC2 first, this is probably the most traditional architecture that you might be thinking about or exposed to in a traditional, I would say, enterprise type of environment, where you can build your service behind, say, some sort of a load balancer. Today we've got multiple load balancer offerings here at AWS, and then you would put that API Gateway in front of that load balancer, and then behind it would be those EC2 instances. We would typically recommend that those be put inside of, say, an auto-scaling group such that it could automatically manage the scale up and scale down of those EC2 instances, based on some sort of a metric such as load or latency. And then what comes with this is a whole suite of other tools that we have here to help you with simplifying the deployment of both these compute resources as well as the code on it. So you can look at services such as CloudFormation or Beanstalk or OpsWorks or Code Deploy, as well as other tools that we have in our Systems Manager suite to help simplify what's involved in deploying your applications. And so in this case, if we were to talk about, a single microservice, it would be this API Gateway, talking to a load balancer, talking to EC2, talking to some sort of data store or data stores. Now, if we talk about microservices with ECS, or really with containers in general, it looks pretty similar to how it would look inside of EC2. We would have some number of EC2 instances running some number of containers, typically inside of them or on top of them, typically fronted then by a load balancer. And so again, you can put API Gateway in front of publicly facing load balancers in front of ECS. This would typically be an application load balancer or a network-based load balancer if you were inside of a VPC. In this case, both application load balancer and network load balancer support container targets, which basically allows you to have multiple containers running on the same host at different ports, whereas a traditional Elastic Load Balancer doesn't have that same capability. Now, we also have a newer container offering here at AWS called AWS Fargate, which provides another level of administrative automation on top of containerized applications. And that's definitely something you'd want to think about checking out if you're looking to, again, simplify even further the amount of management overhead that goes into running an API-based microservice. So we've talked a little bit about this term serverless here, and before we get directly into AWS Lambda, I always like to kind of define how it is that we think about serverless. So for us, serverless means kind of 4 key criteria. No servers to provision or manage. This means no physical, no virtual, no containers that you as an end customer have to think about the life cycle of, the management of, the updating of. You should never have to think about an operating system really at the end of the day. Should automatically scale with usage. So as requests come in, we're going to address and serve those responses back out for you. You should never have to pay for idle. So normally when you're thinking about virtual servers, physical servers, or even containerized workloads, there's some amount of capacity planning that you have to do given the spin-up time that's involved in starting up those resources. Now, auto-scaling can get you to a pretty high level of efficiency, but there's always going to be that potential for a gap where either maybe you have too much excess capacity or potentially too little capacity. With our serverless offerings, this is not something that you have to think about as much. And then lastly, availability and fault tolerance built in. So here at AWS, we have a concept of regions. Inside of regions are availability zones. And building across the availability zones, or building as we like to call multi-AZ, is one of the core foundational kind of constructs for high availability and redundancy and resiliency inside of AWS. With our serverless products, you do not have to think about that. Typically, this is something that's going to be done for you, and so again, it's not a concern that you have to think about from an architectural perspective. At the center of this world for us is AWS Lambda. Now, AWS Lambda is a completely managed compute service that, again, falls into the serverless category here. And the way that AWS Lambda works is you have an event source, in this case an API gateway, that when it receives requests from whatever your clients might be, will go and invoke what's called a Lambda function. Now, your Lambda function contains the code that you've written to complete your business logic, whether that business logic be talking to, say, a database or some other data store, or maybe is capable of providing all of the actions that it needs to on the request inside of just your business logic and your code. The Lambda function will execute that and hopefully complete that action successfully for you, and then return a response back to the API gateway such that it can be sent back up to your customers or clients of your API. There's 5 primary languages that we support today in Lambda, so Node.js, Python, Java, C#, and Go. However, there is actually a pretty rich community of tooling built on top of these languages that allow you to run other languages inside of Lambda. So, for example, there are third-party open source packages for running, say, PHP or Ruby or other versions of Java-based or JVM-based languages. So, brief example here of what a Lambda function looks like. You have kind of the handler, which is the main part of your function that's going to be executed upon invocation. You think it was essentially the entry point into your code. There's something called an event object. This is data that is sent during Lambda function invocation. And in the case of an API gateway-driven invocation, this is going to contain the information passed on by API gateway. So whatever the request is that you've gotten from your client, whether it contains, say, post information or it has a payload inside of it, that information will be sent on as part of the event object. And then you would typically parse that inside of your handler or inside of some business logic in your function. And then lastly, there's the context object. And essentially, you could think of this as capabilities around the environment, the function's configuration that your function could interface with for many different reasons. We won't go too in-depth into this here today, but just as an example. So going back to API Gateway, so I've already kind of addressed a little bit here. We could put API Gateway in front of Lambda such that we can have each individual action and method backed by potentially its own Lambda function. There is a pattern for what we would call a Lambda monolith. This is the idea where you have logic inside of your handler that maybe forks out to different functions or sub-logic inside of a single large Lambda function. It's pretty much considered an anti-pattern these days. We do prefer that you have independent Lambda functions per action off of your API, but depending on your tooling, depending on how you like to code your applications, that can vary. You can also put API Gateway in front of step functions. So step functions is another core component of the serverless story here at AWS. Step functions is a workflow management service that exists around primarily Lambda today, such that you can completely abstract, say, the business logic from a workflow perspective from your code up to step functions, which provide state management for you, such that step functions can do things like decision tree logic, retry, failure handling, parallelization, wait states. There's all sorts of pretty cool capabilities about it. And so you can have an API that acts in primarily an asynchronous way to invoke a step function and do some number of steps or work behind the scene for you. And now lastly, you can actually put API Gateway directly in front of almost any AWS service that you may want to. And so this kind of provides a really interesting use case that we see with some customers where they have, say, a mobile application or an application that lives on a physical device that needs to talk directly to an AWS service, but maybe they want to limit access to it, or they want to have some sort of custom API that masks what the backend technology is. We actually see this with DynamoDB quite often, where maybe you have a mobile application that has a very simple, straightforward, what I would call CRUD interface, so create, read, update, delete type of an API, where it needs to talk to DynamoDB. Now you could potentially expose via federation and other capabilities direct access to DynamoDB, but maybe you want to have your own API in front of it. And so you can actually put API Gateway directly in front of DynamoDB, essentially handle the mapping of the various API calls between the API that you decide to expose and the API that DynamoDB has internally, provide the same kind of authentication or authorization mechanisms that you have inside of your application, and essentially cut out the middleman of another compute layer. And so this is actually a really interesting use case, and I think something that could be really powerful in a number of situations. But for today's example, we're going to pick Lambda as our compute tier. Again, with API Gateway and Lambda, we get kind of the full 4 benefits of the serverless stack. So the ability to automatically scale, to have high availability and resiliency built in, to pay for only what you use, and again, to have very, very little management overhead in terms of operating system management, packaging, thinking about EC2 instances, and so forth. So let's talk a little bit here about securing your API. So again, when it comes to thinking about security, we look at our stack here, we can actually apply security across pretty much all of the various areas that we have. We can secure the ability to log into our mobile or web application via some sort of user authentication. We're typically going to have then some sort of security on the wire, typically today SSL or TLS. Then from, say, our API gateway back to our Lambda functions, we have the ability to secure it via IAM. And then from our Lambda function to our data store, very typically you've got either, say, IAM permissions to potentially something like DynamoDB, or you've got traditional key username, password type key pairs that you might pass for, say, a relational database, or even API keys for another API. When it comes to thinking about doing this with API Gateway, there's a number of different mechanisms that it supports natively. So the first is IAM permissions. And so this is the ability for you to grant out AWS credentials to consumers of your API. Typically, we see this more common for, say, internal API microservices inside of an organization where you have potentially more control over the client or clients that are accessing your API and more visibility into what they're doing. We have custom authorizers, so this is really popular if you're going to be integrating with, say, an OAuth or SAML-based service, or you need to do something even more creative than that. In this case, you can actually have Lambda invoked as part of the authentication authorization step inside of an API gateway. And then lastly, we have another product here called Cognito User Pools. And so Cognito User Pools is a completely managed user management system. I'd like to say it kind of falls a little bit in line here with the serverless products that we have, and that you don't have to think about scaling it yourself. You don't have to manage the underlying infrastructure for it. It's pretty much a completely managed service from that standpoint. And so, across these various options and capabilities that exist here, depending on whether you need things like third-party authentication, whether maybe you have to support things like multiple headers, maybe you need to do things like use signature v4 if you're interfacing with other AWS services. You'll probably have at least one of these options, sometimes one of the options plus another to complete what it is that you're trying to do. As you see here, Cognito User Pools gives you quite a lot of the capabilities here, and so we're going to talk a little bit further here about Cognito itself. So again, Cognito User Pools is a completely managed service for managing users that might be accessing an API-based service. Typically, in this case, we're talking about users that are primarily human or human-driven applications or devices. So for example, if you have a mobile-based application, you can handle the authentication of your customers via Cognito User Pools. And in this case, Cognito can help you with things like user sign-up and sign-in. It has a number of capabilities around things like resetting passwords, gathering information, like profile information from your customers in terms of whatever a profile might mean for you. It supports capabilities such as multi-factor, so whether it be token-based multi-factor or the ability for you to do things like verify email or phone numbers. And so, pretty strong service for giving you the ability to manage your users without you having to think about doing this yourself. Number of built-in user workflows. And again, provides a very low management overhead capability for doing this. So where do you start with all this, right? We've made some technology decisions. API Gateway and Lambda provide kind of the core of our API management system from providing outbound access to our API as well as the compute tier. Services such as Cognito provide us with the ability to, say, authorize and authenticate our customers' access back to our APIs from a number of different applications. But I actually want to now, go and build an API. Where do I want to start? Well, if we were just talking about building the raw API itself, API Gateway does support Swagger, or what's now known as Open API Specification, or OAS. And so Swagger as a technology has been in the industry for a number of years now. This is the ability for you to basically have a template-driven system for representing an API. And so here at AWS, for API Gateway, we have some extensions that are specific to our technology and our products. But there is actually a pretty rich ecosystem of third-party tools that will help you create these. There's a number of different providers that you can use a Swagger document to help with both, say, automated testing or automated monitoring of your APIs. And so we find that Swagger is kind of one of the core languages essentially of the API world from a DSL perspective that allow you to define and manage your APIs. So definitely encourage you to become familiar with Swagger, understand what it's capable of, because there's a very strong likeliness that you'll end up touching it if you're going to be building APIs this way. When it comes to thinking about purely serverless-based APIs, we do have also a pretty rich ecosystem of frameworks that exist in the serverless space. These frameworks will have varying differences depending on the languages that they support, the use cases that they support. Almost all of them today support APIs as kind of a core use case for what they're capable of. Some of them, though, have special modules for, say, things like chat applications or Alexa functions, or Alexa skills, I should say, sorry. As well as maybe some that are broader than that. Some are also very language specific, but we see kind of a couple of these being the core frameworks that we see out there. So Apex, AWS Chalice, which we'll talk about here in a moment, ClaudiaJS, which I'll also talk about here in a little bit, Serverless, Sparta, and Zappa. These are some of the most core frameworks out there. There are a whole bunch of them that exist, and depending on your need and your use case, you can definitely find a third party that's got one out there tailored for you. I definitely encourage you to start with one of these versus attempting to build your own type of tooling in this space, as this will greatly simplify your life. So let's take a couple of examples of these here. So ClaudiaJS, one of the more popular JavaScript frameworks that's out there, it has specific capabilities for building APIs and chatbots. And so if we look here at an example of what you can do with this, we've got roughly about 5 or 6 lines of code inside of this very basic file. And what's going to come out of these 5 lines of code and then us running the command line right below here is an API gateway, a Lambda function, the two of them configured so they can communicate with each other, and a very basic kind of API that will return a hello world when we go to /hello, effectively the API route. So really super easy to get started here, and obviously you can get much more complicated from this. But again, 5 lines of code basically generating for you the infrastructure side and the application side is really pretty powerful. Now we see a similar thing in Chalice, which is actually a tool that came out of the AWS API and SDK team. This was something that team had started to build internally to help them with launching their service, which again, their service is the SDKs and the APIs that we provide here at AWS. The team used Python pretty heavily, and so they started to work on a Python framework for this, and eventually open sourced it, and it's grown in popularity. And so very similar to Claudia here, we see about 5 lines of code. We run a command at the bottom, and what that's going to give us is, again, an API gateway, a Lambda function with very basic capability inside of it, all of the appropriate permissions and kind of configuration for gluing these two things together set up for you. And so again, it's really, really easy to get started building APIs in this new kind of serverless architecture world. Let's go a little bit deeper into this. So sticking with Chalice here for a moment, just as an example, and again, pretty much all the frameworks that I showed previously have very similar capabilities to this. But if we were to take a pretty straightforward API, we could expand out to a number of different API functions, or as Chalice calls them, application routes. We've got things like helpers for things like error handling, for HTTP method support. And so instead of us having to think about writing the code to handle this yourself, you can use the helpers in these frameworks to, again, kind of grease the skids on getting started and moving much faster. If we look at what's required for us to add our authorization to this, adding Cognito user pools as an authorizer for our API is really straightforward. We basically import a certain package, we configure where our authorizer is configured to, and then we add, very straightforward here into the 2 routes that we see here, authorization for, certain methods for those routes. And so again, what this will help us do is automate the configuration of API Gateway, knowing that it needs to use Cognito user pools, this specific pool in general, which API functions it is that are going to need authorization. And again, basically you take this file, you run the command line tool, and it's going to build all this for you. So we definitely encourage you to take a look at these frameworks. They're going to make your life, much easier than if you were doing this, say, from scratch in the console with our CLI tools with CloudFormation. Let's assume that you don't want to, go into using one of these frameworks. What are the other options that exist out there? And so another option that you do have here from us here at AWS is a tool called AWS SAM, or Serverless Application Models. And you're seeing here our friendly squirrel mascot. This is Sam the squirrel. And so SAM represents the serverless space for us here. And so what SAM itself is, though, it is actually a tool for helping you manage applications. So it is an extension built on top of CloudFormation. So it still uses the same kind of syntax and notation as CloudFormation. It supports YAML or JSON. And at the end of the day, you use the CloudFormation service to launch these resources. But what SAM does is it provides for you 3 specialized resources today. Function, an API, and what we call simple tables. And so what this does for you is it greatly reduces the amount of work that you need to do in configuring and building out these services. Again, what this does is, since it's built on top of CloudFormation, it actually supports all of the capabilities of CloudFormation beyond just these 3 resource types that are specialized for it. This is part of actually an open source project that we've launched. So very recently, we took the entire transformation service behind the scenes for SAM and open sourced that and released it out there. And we are very actively, accepting community pull requests, issues, and feedback, and so forth. And so you can find that at the GitHub link on the bottom of this slide. So let's take an example of a SAM template. This is a very straightforward kind of SAM template that we would see, every day of the week here in this space. The SAM template really kind of has 3 things going on in it. The first is that it has a header section. In this case, we see what's called the AWS template format. Then we see a transform line. And so the transform line is actually the key part here. This tells the CloudFormation service that this is a special type of CloudFormation template, and you're going to need to take some of these resources and transform them out into other resources. We then see 2 actual resources inside of this. We see an AWS serverless function and then an AWS serverless simple table at the bottom. The simple table is actually just a very light wrapper around DynamoDB. It gives you a very basic DynamoDB table with a base number of read and write units configured. And so this can, just get you out the door, starting with a service. But now if we look at this serverless function here, there's a bit more going on. So we have a number of properties around configuring our Lambda function, where the code lives, where the handler is for our function, the runtime that we want to use, a policy that we would want to use for this. In this case, it's referencing a managed IAM policy. And then we see here at the events section, an event that we have called getHTML. It's of type API, and it has 2 properties, a path and a method. And essentially what this does is it tells CloudFormation that this is an API-driven Lambda function. We want to glue the 2 of these together and create our DynamoDB table for us. And so roughly, if we were to think about these, roughly 15 or 16 lines of code, this expands out to about approximately 80 or 90 lines of raw CloudFormation. And so this greatly, again, simplifies the work that you need in, writing the templating language for managing these resources. One last way to think about this here is that we have a public example that you can go and find up on GitHub, where roughly from lines 9 to 25 in this example here of a SAM template corresponds to the creation of approximately 7 different AWS resources. So we have an API gateway, we have an API gateway stage, a deployment, a Lambda function, permissions for that Lambda function, and a policy for it. So again, SAM is going to simplify your life. It has nothing really about it that is specific to the language or the use case that you have. So unlike the frameworks, which are typically language-based, typically tie back to a single use case, SAM is meant to be a very flexible tool that kind of cuts across that. And actually, a number of the third-party frameworks out there today have the ability to generate SAM templates for you or built on top of SAM. And so what this allows us to do, or one of the great capabilities of SAM, is that we now have a localized tool for doing serverless development with SAM. So back in the summer of 2017, we launched a tool called SAM Local. Just a couple weeks ago, we basically relaunched this product. It's officially now just called AWS SAM CLI. It's been actually rewritten from the ground up. It's had a whole bunch of work and features added to it. But what SAM CLI allows you to do is to build, debug, and launch serverless applications from your local development environment. So what it can do is take a serverless application, launch it inside of a Docker container running on your own workstation, such that you can test API-based serverless applications. You can also test invocations for non-API workloads as well. But SAM CLI is a tool that we're finding is becoming a regular kind of core component of our customers building in this space. Cool. So we've talked a little bit about what's involved in you actually building your APIs from a configuration standpoint, from the standpoint of potentially getting started even with building a full serverless application. Let's talk about what's required about actually putting this code into production at some point. So as part of API Gateway and as part of APIs, we have a concept of stages. You could think of stages, kind of being the equivalent of individual environments that might exist for an application, such that you could have dev, test, prod, or maybe you call them alpha, beta, gamma, whatever it is that you use to represent these. And so API Gateway supports the ability for you to have the same configuration across multiple different environments and be able to deploy against those as you see the need to. As part of this, API Gateway also has a concept called stage variables. And so what stage variables allow you to do is pass in information to the underlying backend resource, basically to allow you to have a little bit more dynamicness as part of your application. So your application can consume these stage variables and then have some more context about what stage they're running in, as an example. So these are passed back, just a kind of a key value store, if you will, as part of the service. And then these are then accessible, again, from typically the backend, the event context that is passed to them. And so what this allows us to do is, say, have a single Lambda function that takes in information from our API Gateway request and know that, okay, this is a Lambda function for, say, again, dev, testing, or prod, versus having to necessarily have separate functions for those different environments. And so what we can actually do is have, say, our Lambda function and have our API Gateway stages, such that we have API Gateway stages that map back to certain versions and then aliases of a Lambda function. So inside of Lambda, we have a concept of versions. It's basically just an incrementing number that represents your code at a certain point in time. You can then assign to those various versions what are called aliases. So we see here as an example that my prod, which is currently version 3, exists. And then I have version 6, which is labeled as beta as an alias. And then in my API Gateway, I have aliases that would essentially, via stage variables, point back to those environments. So I can have my prod stage represent my prod Lambda function, beta represent beta, and so on. So pretty straightforward here. And we could imagine a world where, as I want to promote this code from one environment to the other, I could just very easily, for example, take the alias and say move prod from version 3 to version 6, and then that would shift traffic along with it. Now, one of the great things about API Gateway is it supports the ability for us to control the shifting of this traffic. You could imagine that if you were going to flip that alias from prod to beta all at once, or say maybe update your backend on a traditional compute environment all at once, there is definitely that potential for you to impact your customers. And so what Canary support allows us to do is to actually direct just a percentage of traffic between two different stages, such that we have, again, the ability to say, send 5% to this version of my application or my API and send the rest to the previous version of that. And so it's pretty straightforward, pretty easy, just kind of like it sounds here. And what this allows you to do is do things like explore, not just say, a new code version or a new capability of your API, but potentially explore, new languages, new frameworks. Maybe you're on a traditional compute-based API and you want to test out Lambda for certain functions or certain API methods or actions. This is something that Canary support could very easily do. You could also use it as part of a migration. So let's say that you did have an API that was based on, on-prem or another cloud or wherever it might be publicly accessible from. You could actually use API Gateway to move, method by method, action by action over from one backend source to another. So again, here as an example, assume that I have a certain API, it's version 1. I'd like to go out and explore, deploying version 2. I can take version 2 and shift just 10% of my traffic to it, essentially to that canary. And what I'm going to get here is unique logs, unique metrics for that new version. And so I can leave this version out for a certain period of time until I feel comfortable with the fact that I've been able to test this appropriately. And then once everything is good, I could shift all the traffic over to this new version. And again, from the client perspective, there's nothing that needs to be done. I don't have to think about writing any sort of client logic. All of this is going to be transparent to my end clients. So speaking about these clients, how can I connect my clients back to my API gateway? So API Gateway has the ability to generate SDKs for you. And so you could do this across a number of different ways. I'm going to use the example here of using a Swagger document as kind of the source of truth for my API. So I am a service developer. I have created a Swagger document, or generated a Swagger document for my API. I'm going to take that and, let's say, configure my API gateway with it. From here now I can execute a generate SDK call, whether it's be in the console or CLI or API. And what this is going to return back to me is a zip file containing code for the language that I selected. So in this case I selected Node.js. Now I could just take that code and put it into any other application, but one of the things that I personally recommend to our customers is you might want to think about actually putting this into more of a native package for your language, such this can be included as part of a development lifecycle a little more cleanly. And then you can actually take this package and say put it into a artifact store or repository service, whether that be something like Nexus or Artifactory, packagecloud.io, the public NPM repositories that are out there, whatever it might need to be, that's up to you. And then it could be obviously consumed by your clients. And so your clients don't have to know much in this case about how to build your API. They can just execute against that. And then let's say now that we want to put out a new version of our API. Well, it's pretty straightforward. We can walk back through this process again, present out our new package to via our private repository to our clients. They can consume it as necessary. And then again, what's possible, given that we have stages, given that we have stage variables, given that we have canaries and so forth, is that we can support multiple versions of our API, support multiple clients of our API without, say, having to make a hard shift of moving everyone over all at once. We can assume at some point then that we do deprecate an old version, and depending on your internal development tooling, it could be easy to just say, hey everyone, you need to move over to this new package, update your requirements.txt file, and away you go. And so what a pipeline might look like for developing this API, at least in a serverless world here, is a pretty straightforward one as we would consider here at AWS. This is a deployment pipeline that has what's considered 5 stages. We have a source stage, a build stage, and then 3 environmental-based stages. And in this, we'd be deploying our application out to, again, several different environments and testing them along the way. And so, again, we could have various tests, whether they be automated, whether they be physical, done via, say, like a QA team. We see, for example, a manual approval step in the middle of the deploy staging environment stage. And then at the end here of our pipeline, we could then, say, generate an SDK and go through the SDK generation flow that I was just talking about. Cool. So, in closing here, again, it's never been easier to get started with building an API. Whether you're talking about using one of the frameworks that we mentioned here in the serverless space, or you talk about using, say, tools like Swagger to help configure your API gateway, when you think about what it comes down to managing an API, for scaling an API, your products like API Gateway are going to remove a lot of that burden from you, helps you standardize authentication authorization interfaces, allows you to plug into specialized tools for that, such as Cognito, comes with built-in monitoring, logging, and other capabilities such as Canaries, and also allows you to do things like SDK generation. And so all of those are pretty powerful capabilities that, again, are here to help simplify your life as an application developer. Now, again, this is kind of a quick overview of a number of different capabilities. There's a lot more that we can go into here. I would encourage you to take a look at the API Gateway landing page, so at awsamazon.com/API Gateway. You can read more about serverless applications at aws.amazon.com/serverless, as well as you'll get a link here after this webinar concludes to the recording for this, as well as where you can find other recordings posted on YouTube and slides on SlideShare. I've got a couple minutes here for questions, and so I'm going to attempt to go through here as many of the questions as I can. So give me a second here to read through some of these and try to get through this.